Hello everyone. So once again we are live and now we are completing the RAG interview question. So this one is the part 2 of day 1. So we will understand we already understand what is RAG and also studied about the end-to-end RAG pipeline and also what is chunking, what is embedding things. And so next question, that is the most needed question or most important question. So the question is that what is the vector database and the vector stored in RAG? So what is vector database or a vector stored in a RAG? So vector data database and database and or vector stored in RAG. Okay, so let's discuss this question. What is this? So so a vector store embedding and supporting similarity search over them. Okay. So like vector which store the embedding and support similarity search over them. And its job is to quickly find document chunk and that are closest to the query embedding. Okay. And in production RAG, the vector store is a retrieval engine behind the semantic search. Okay. So we can say that a vector store. So vector store the vector store. Okay. So vector stored what? Embedding and support similarity search. Support similarity search. Okay. And and its job is to quickly find a document. Its job is to job to quickly find the documents. Okay, document chunks and closest to the query embedding things. Or in the production, if we say that in production like vector store its retrieval engine behind the semantic search. So it may only store metadata in production. So in production, in RAG, the vector store it retrieval engine. So like vector store retrieval engine. Okay. So a retrieval engine behind the semantic search, and it may also store store the metadata like source, timestamp. Okay, timestamp, access permission. Okay, access permission and document IDs. So doc IDs, all these things. And so best to answer this question. So best to answer this question, we can say in one line that is vector store vector stores make retrieval scalable. Okay, fast and semantically aware. Semantically aware. Okay, aware. Okay, so so vector database and the vector store. So vector store the embedding and similarity search, and its job is to quickly find a document chunk and also find a closest query embedding things. So if you are talking about the RAG in production level, so vector store its retrieval engine behind the semantic search, and it may also store like metadata like source, stamp, access permission, document IDs, and this vector store make a retrieval more scalable, fast and systematically aware. Okay, let's move to the next question that is about, so that is about like, one second. So the question is that uh, why does the RAG use semantic search instead of the keyword search alone? So like semantic semantic tick search over like keyword search. Okay, keyword search. Okay, keyword search. Okay, so why like RAG support in context of the, we are talking about the RAG. So why this? Let's see. Why this RAG support semantic search over this one. So keyword search depend on the exact word overlap. So that keyword search like exactly depend on the exact word overlap. So it depend on the, so we can say depend depend on exact word overlap. Okay, okay, and so it can miss a relevant content when the wording are different. So it like misses many relevant words which are not matching, which are not exactly, which are not exactly we can say exactly matching. Okay, so like okay, so semantic search use embedding. So in the searches, semantic search use embedding. Okay, so in embedding to match meanings. Okay, not just a literal term, just in embedding it matches the meaning. Okay, not just the not just a literal term. Okay, literal term. So this is useful for the paraphrase question, domain jargon, and the natural language query. So that said that keyword search can still be valuable when the exact term or code or name matters. Okay, the strong system, like a strong system often combine both approach for the better recall and precision. So like both are good for the strong system, for the strong system still system require both like keyword search plus semantic search. Okay, to make the system more like make better recall, to make better recall. Okay, recall and and more precise, more precision. Okay, so let's move to the what is hybrid retrieval. So what is the hybrid retrieval? Hybrid retrieval. Okay, so for this one, for this one we can say that we can say that hybrid retrieval is a combination of the keyword search like systematic. This technical term is also known as like hybrid retrieval is a combination of keyword search plus semantic search. Okay, this help because semantic search is strong on meaning while keyword search is strong in the exact this one. Okay, so now keyword search is like strong in the thing like a strong on the exact matches. Okay, exact match. Okay, whereas the semantic search is a strong like strong in semantic search. Okay, mm, strong in the semantic and strong on meaning. So it's strong on meaning. Okay, so this is also known as the retrieval search. Okay, and let's move forward. For example, the product ID, error code, legal clause, number, medicine name may work better with the keyword matching. Okay, so like when we have to explain about the hybrid retrieval, so like we have to say that hybrid retrieval is a practical way to improve recall across different query, and it is often used enterprise RAG system where both precision and coverage matter. Okay. Okay, so what is re-ranking in the RAG? So re-ranking is the second stage ranking step that reorder the initially retrieved result. So retriever may be result many candidate, but not all of this accurately. And one more thing we have to discuss: what is the role of metadata in the RAG? Uh, so what is metadata? Metadata is like the information of that data. So what is the role? What is a role of like metadata? Okay, metadata in RAG. Okay, so in that case we can say that like metadata help to filter, organize, and read like trace the retrievable document. So in like it help me in filtering, organizing, organizing, and tracing the retrieve document. Okay, traces and retrieve document. For example, like it include document sources, department, date, language, version, and access level. So metadata filtering can be dramatically improved and retrieval quality by narrowing the search space. Okay, it also help in the compilation and the provenances, so which are very important to enterprise system. So if in interview it may ask, so like I have to like mention a RAG more controllable and auditable. Okay. So one more thing, that how can we reduce the hallucination using RAG? So this can be also asked, how to reduce. So how to reduce hallucination. Okay, hallucinations hallucinations. Okay, using RAG. Okay. So RAG reduce hallucination by grounding the model in retrievable evidence. So okay. So in that case, I have to answer that RAG reduce by what? Grounding, grounding the model. Okay. Grounding the model in the retrieved, okay, retrieved evidence. Okay, instead of grounding the model in retrievable evidence, so instead of relying only on the parametric memory, the model see the supporting context before answering. Okay, so instead relying on the parameters, so parametric memory. Okay, instead of like relying on parametric memory, the model sees supporting a context before answering, supporting context before before answering. Okay, and this make it more likely to respond with the specific factual and relevant information. Okay, however, RAG does not eliminate the hallucination completely. I know, like we can't say that RAG we can't say like like say that rag fully fully eliminate eliminate the hallucination. Okay, so it bad hallucination completely, but bad retrieval can be still wrong answer. So strong point is that a grounding help that a grounding help, but retrieval quality and the prompt discipline still matter. Okay, so and what are the main failure point of the rack system? This I think. So this one last question for today's topic. Okay. So the thing is that, so what are the main failure points? So I have to explain the main failure point in RAG, main failure point in a RAG system. Okay. The most common failure point are poor chunking things. Okay. So are the points are this one like poor chunking, weak embedding. Okay. Weak embedding. Okay. Weak embedding, bad retrieval, and noisy prompt. And and the thing is like noisy prompt. Okay. And if retrieval misses the right context, the generator cannot answer well. Okay. And if the context is long, if the context is too long or irrelevant, the model may become confused and waste token. So other issue include like stale data, duplicate chunk, access control mistake. Okay. So these are the like main failure point if we have poor chunking thing, poor, weak embedding and bad retrieval and a noisy prompt. And in that case, like our system like response less confuse and waste the token. Okay. So this might be the question we can expect from this RAG interview. Uh, During the interview, these are like 10 questions which I'll follow. So also many questions that I can just read here. Why do we choose chunk size? So like, what is the importance of using the chunk size? So there is some single perfect chunk size. So it depends on the document type. So chunks should be large enough to preserve the meaning, but small enough to retrieve the precisely. Okay, and why? What is the chunk overlap and why it's used? So for that we have to answer like chunk overlap means repeating the small text between adjacent chunk. Okay, and what is a dense retrieval and the sparse retrieval? So dense retrieval using embedding and vector similarity to retrieve the similarity related content. Sparse retrieval usually relies on the keyword frequency method such as lexical matching. So how do we evaluate a rank system? So rank system usually have two level, retrieval quality and answer quality. Okay, for the retrieval you can measure whether the correct document chunk appear in the top k result. Okay, for the generation we can check the factual accuracy, groundedness, completeness, relevance. So human review is still important, especially in the enterprise regulated domain. Okay, so evaluated basis on the retrieval quality and the answer quality. And these are the question. And one more thing, that what is the prompt guiding the RAG? Okay, the prompt guiding mean that explicitly instructing the model to use only retrieve context when answering. Okay, so like prompt like you can here write like prompt guiding is important. Guiding guiding is important important in the RAG system. Okay. So like prompt guiding mean explicitly instructing the model to use like retrieve context when answering. So this help to keep the output keep the output tied to a source material. Okay, the output will be like given like tied to like source, some source. Okay, some source, and reduce the what and reduce the unsupported generation, unsupported unsupported generation. Okay, and the grounded prompt may also ask the model to cite source and refuse when evidence is missing. So grounding is one of the main reason RAG is preferred in the enterprise. Okay, why the source citation important RAG? Okay, so what are the security concern we face? So many question like security concern using RAG. So security concern include access control. In security concern, we can say that like we can say that like access control. Okay. Mm, access control, maybe data leakage thing, data leakage. Okay, and prompt injection through the retrievable document. So prompt injection through retrieval to the retrieval retrieved content. Okay, and if a user should not access certain document, the retriever must enforce the permission before retrieval. So you also need a validate and sanitize the content from the untrusted sources. Okay, so in a enterprise setting like metadata filtering and identify a retrieval. So like a RAG must be designed as a secure information, not just an AI feature. Like it is a like secure information system. Okay. So like how we improve the retrieval quality. So you can improve the retrieval by better chunking, better embedding, meta filtering, re-ranking, query rewriting, query expansion can help when the question are vague. Okay, like structural domain, hybrid search, domain specific preprocessing thing make the retrieval more accurate or improve the retrieval quality. Okay, so can RAG work without vector database? One more question. Yes, but the system may use another retrieval level such as search indices, keyword search, hybrid retrieval. So that the essential requirement is not the vector database itself, but the ability to fetch the relevant context at a runtime. Okay, we know that RAG running on the vector database, but if we remove that vector database, it can be either run on the search indices, keyword search, hybrid search. But the essential is but essential part is that ability to fetch the relevant context on the runtime. That say that vectors store a common things because the semantically similarity often very effective for the natural process and natural language question. Okay, so vector database is useful, but RAG is rely on the design pattern, not on the single tool. Okay, so if the last question is that what should you say that if summarize a RAG is one of the strong like question. So I can say that a RAG is an architecture that improve the LLM answer. Okay, so like summary part for RAG. So I have to say that summary part of the RAG, I can say that the RAG is an architecture RAG is the architecture that improve the that improve the LLMs LLM answer, okay, answer by retrieving the retrieving the relevant, okay, relevant external knowledge, okay, and retrieve external knowledge at a query time, and feeding it into the generator, and feeding feeding into the generator, okay, and it is used to make response more factual, make make response more factual, okay, and more factual, current, okay, factual, current, and domain specific, okay. So main component, or we have to say what are the main component for this one is that main component. So it is used to make something uh, like domain specific, and main component are the injection, chunking, chunking, embedding, embedding, okay, embedding and retrieval, 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 then re-ranking, okay, re-ranking, prompt guiding, prompt guiding. These are the guiding and like an answer generation. So it successfully depend heavily on the retrieval quality, context quality, and the secure data. So like that's all for the RAG question. These are the like sufficient question. These are the sufficient question. You can go through all these question. So to understand what is RAG, retrieval augmented generation, like application. The pattern is like for the application. Uh, so like what is the first line? So it like it's a pattern where the application first retrieve the information from the external source and give this information to the LLM, and LLM generate the final answer. Use cases, you know that the use cases to make response more like grounded and easier to verify. And then we have to see the difference between fine tuning like RAG. Fine tuning change the model with the weight, but RAG simply inject the relevant, like RAG like fine tuning change the model weight, and while the RAG keep the model fixed and inject the relevant information. And fine tuning is uh, better for the behavior style for betting task pattern, but RAG is much better for the fact in company's knowledge and face update. Okay, then we see the pipelines of the RAG. So the typically RAG pipeline start with the document ingestion, then after do chunking, then embedding, and then indexing into the vector store. Okay, at the query time, the user's question is also embedded into this store retrieve semantically similar chunk. So those retrieve chunk are added into the prompt and context into, then LLM generate the final answer. Okay. And then why the chunking is important in the RAG? So chunking break the large document into smaller document segment, and that can be that can be embedded and retrieve more precisely. So if chunk is too large, then the retrieval will become noisy and context heavy. If chunk is small, then important meaning like if chunk are too small, the important meaning may be lost. Okay. So good chunking improve the retrieval quality. What are the embedding thing that thing we're talking about? So like embedding are the numerical vector representation of the like Like embedding are the numerical vector representation of the text that can capture semantic meaning. Okay, so in RAG, both document and the query in both document and query are converted into embedding so that the semantically similar text can be matched. Okay, so we can say this is why can retrieve relevant passages even when the exact keyword don't match. Okay, so we can set embedding at the bridge between the language and the vector space. Then we see the vector databases like vector store embedding and supporting similarity word. But its job is to quickly find the document chunk that are almost closest to query. Okay. So semantic search or like keyword search, role of metadata, how to reduce the hallucination, main failure point of the RAG, and like prompt guiding in RAG and the security consent and summary. So that's all. We wrap up this RAG session in two session. So like let's join for the next important interview question for like software development. Okay.